Server partitioning with Dan Guzman. That's all right. The August meeting is going to be the BI meeting. It's an afternoon meeting. It also will be here, and it's powered with Microsoft. It's going to be Angry BI. Don't ask me. I've got the little thing to write up for it.
Yes.
We are part of the Professional Association of SQL Server, the PASS organization. And here's the community news. 24 hours of PASS. It's free education. Go and register. It's coming up July 19th and 20th. It's 24 hours of lectures. Kind of gives you a preview of what's coming to Summit, which is great. The PASS Summit, like I said, this is coming. This is the premier SQL Server conference. It's out in Seattle again. They have an all-in-one bundle, which gives you the two pre-cons, or they have just the summit. The full summit is $18.95, and if you use our discount code, we get $150 off, and then PASS will give us a little something to help run the organization, the local community. But if you have any questions about attending PASS or about PASS, I'm going. Gary's been, Dan's been, Kathy Kellenberger is a frequent speaker. Have you spoken at PASS too?
I haven't spoken. No. Not yet.
So there's a few of us. Oh, Dan over here from Washington, he's gone. He's going to go in. Just come and ask us questions. What's about? It's, you know, they have a lot of different tracks. There's professional development, as well as, you know, developers, database administrators, BI. This runs the gamut. There are virtual chapters within PASS, and here's some upcoming meetings. And even though we are a physical chapter here and you have us as an opportunity, please go out and take your PASS login and associate with any of the virtual chapters you're interested in. You'll only get emails about the meetings. They usually meet monthly or a couple times a month. Kathy is the co-chair of the Women in Technology group. They have some great lectures. You can participate and ask questions during the lunch and learn, or all the recordings, all of the meetings are recorded and are on their websites as well. Here's some more meetings. And then this is just a sampling of all the different groups that we have for virtual chapters. SQL Saturdays are one-day mini conferences. So these are the ones coming up in July. We had one last year. We're not having one this year. So we'll see if we can get organized for next year. And these are ways that you can stay connected. So this is all about Dan, and I'm always so jealous, you know, because he's been working with SQL Server since 4.2.1, and I started at 6.5.
Well, you don't want to work with 4.2.1.
No, and I was not thrilled with 6.5. 7.0. I was like, whoa, they're finally catching up to IBM and DB2. But he's very active in the SQL community. He is on the board of our SQL Server user group, and he is Microsoft SQL Server MVP since 2001. We really appreciate all the effort he puts into the groups and speaking for us. Kathy Kellenberger is here. She's going to be recording the meeting tonight, so we can post it on our website. But she's a local MVP as well. So we have a lot of experts. We're very blessed to have these experts in St. Louis who want to get back to the community. So don't forget to get your, do people need your eval sheets? Okay.
Well, speaking of email sheets, please do fill those out. I really appreciate any sort of constructive feedback and comments you might have. The idea is to make the presentation better every time I do it. And then maybe has anybody seen this one before? My table partition presentation. Okay. I've given it a few times here in St. Louis. Dave.net, I think here at Oakwood, they had a SQL relay event a few years ago. I gave it there, well as a SQL Server user group, not the BI, one, but rather the SQL Server database one. But there's a lot of use cases for, partitioning BI space too, and that's why Bill told me to speak here today. So that's what I'm going to talk about today, table partitioning and view partitioning as well. I'll first discuss a few of the use cases why you want to partition your database objects, and then discuss some of the concepts related to that, as well as table and view partitioning, and talk about automating partition management. How many of you have used table or partitioning at all before in your database? I only see a couple of hands. That kind of surprises me. How many of you are running Enterprise Edition? A lot more, okay. Because prior to SQL Server 2016 Service Pack 1, partitioning required Enterprise Edition. However, beginning with Service Pack 1 of SQL 2016, you can actually use partition and Columnstore and those features in the standard SKU. Microsoft, that's kind of unprecedented for Microsoft to do something like that. Usually they'll kind of charge the big bucks to use the big features, and partitioning is definitely a pretty big feature as a Columnstore. So, if you are using standard edition, that's definitely an option if you're on the latest version of 2016 Service Pack 1. So go there if you can. The reason you would partition, tables is mostly for manageability, especially if the tables are big. Now, the question that people ask me is how big is big? And I can't answer that question. What I can tell you is that if it's painful to, meet your nightly maintenance windows because they're taking a long time to rebuild indexes, if your queries are running a really long time, and you have short maintenance windows, those are things that kind of make it painful to have a lot of data in your tables. And a lot of people, what they'll do is they'll purge data out of their tables or archive it into a different set of tables. Well, with partitioning, you don't necessarily have to do that. You can have one big table or entity that has all the data, even going back for several years. And you'll get the same level of performance if you have a lot of attention to detail with regard to query index tuning. Partitioning isn't magic. You still need to do the normal stuff you do to, tune your database. But at least you have a lot more options. Another use case is to reduce your recovery time if you have a very large table. For example, I worked with a table that had, I want to say about 10 to 15 years worth of historical data in it. And the thing is just huge, multiple terabytes. I think it had 60 billion rows last time I checked. I mean, the thing is just a monster. And to restore that thing takes a really, really long time. Well, our DBAs, they went through the trouble of splitting the historical data into separate file groups so that if they do need to restore the database, they can do it in a piecemeal fashion, where they start by restoring the new data so that users can have access to the data they need right away, and then restore the older data separately with a piecemeal restore process, more or less for convenience. But that way, at least the data is available, even though it's all in one huge table. Now I'll get into some of the details a little bit later today. You can separate the active data from the the read-only data. If you have historical data that is never going to ever change, you can put those on read-only file groups. And since the file groups are read-only and never change, you don't have to back them up every night and defer that. Really save yourself a lot of resources that otherwise would just be wasted. You don't want to keep backing up the same data over and over. And in situations like tiered storage, where you might have some expensive SSD that's really fast, yeah, you also have something like a old folder, spinning media, maybe not on the same or something. You can segregate that data so that your heavily accessed data is on the fast stuff, and your slow, storage is used for the infrequently accessed data. So partitioning is an enabling technology for those kind of scenarios. So one of the cool features about partitioning is the ability to load or purge data on individual partitions in one fell swoop without having to, like do a delete and an insert of a large amount of data. It's especially handy if you're doing an ETL process and you want to refresh or, either an existing partition of data that's logically segregated, or if you want to be able to just do like a load into a staging table and just refresh a main table, just periodically. The actual process for doing that I'll show in a second, but it's very, very fast compared to traditional ways of deleting or truncating and then inserting. Partitioning can improve performance of large scans through partition elimination when no useful traditional index exists to facilitate that query. Again, it's not magic. I mean, it's better to have indexes if you can, but you can also augment that with partitioning to at least scan only the data, a smaller set of the data instead of scanning the entire table. And I'll demo some of that as well. Out of curiosity, does anybody use Columnstore indexes here? Does anyone? No one? Wow, that does surprise me, frankly, because especially in the BI space. Well, I'll show later, but it is the best thing since sliced bread, in my opinion, especially with SQL 2016 or 14 for that matter, where the Columnstore indexes can be updated. They're updatable, so you can have essentially real-time analytics of large volumes of data. But at a high level, all partitioning really is dividing rows into subsets of data, based on the partitioning column, the column value. So, for example, you could maybe that partitioning value might be your order entry date. It could be a store code. It could be virtually anything you want. But it makes sense to group the data logically and how it's actually used. Mostly I'm going to focus on partitioning based on some sort of temporal type, like a date or a date time, those sort of types, where you always have a lot of new incoming data that you're essentially appending onto the end of an existing data set. That's one of the sweet spots for partitioning for a number of reasons, but that's by far the most common use case I see. I'll mention it later, or I'll mention it, but it's not used as often, is the ability to, let's say you have a company where your stores are divided into regions. You might have one partition for each of those regions, and as part of your ETL process, you refresh one region at a time. What you could do is, partition by region, and then just process, each store individually, rather than processing everybody, the entire organization. It is a big change when you partition a table. It fundamentally affects how the data is stored on the database, as well as the query planes themselves. So it's something not to be done, lightly. But there are a lot of benefits. Ideally, the partitioning should be transparent to all your queries, just your regular select, insert, update, delete, merge, yada yada. And also, the key is that when you have a row, it belongs in exactly one partition, no ambiguity. It's not like it might go into partition 1 or it might go into partition 2. It belongs in a single partition within that. This diagram sort of illustrates what a non-partition table looks like, where you have a clustered index, where you have the data is organized into a standard B tree. So if I want to read a single row by the clustered index key, I would start at the root, work my way down into the intermediate leaf node that has that. So it starts at the root to find the intermediate node that has that key, goes to that intermediate node, then down into the leaf nodes, which are the actual data pages for a clustered index. A clustered index is logically ordered by that clustered key, like all B-tree indexes are. But the differentiator with the clustered index is that the clustered index leaf node is the data page. It has the row of the data that is in your table. Whereas with the non-clustered index, it's also a B-tree. The only differentiator really is that once it finds the key in the leaf node, so if I want to look up by not the clustered index, we just follow the tree to 1, 2, 3 reads, and that leaf node would then have the pointer to the data page over here, which is really a clustered index key. So what it would do is it would read, go back over to the clustered index and do read. So for the 6 logical IOs, it'd be able to read that row of the database. So one of the performance metrics that I like to use when analyzing, the cost of a query is how many logical IOs it takes to get to that page. And I'll do that in a minute here. So starting with 2005, which is like ancient history here, SQL Server, every table is actually sort of partitioned. It's partitioned at the storage level, as I showed it in the previous slide, where it's one table without boundaries, but it's still stored in the physical partition, and it's an independent structure there. That's the table. What that does is it allows one to actually switch the table, all that storage, from one table to another table, as long as the schema is identical and the file groups are identical. So the only restriction is that besides being on the same file groups and having an identical schema, the target table has to be empty. So if I have a table full of data and I switch that table into another table, that data, that source table becomes empty, and the target table suddenly miraculously has all the data that was written in the source table. So that's a really cool thing for ETL processes especially, because what you can do then is say, I want to refresh this months of data or this store of data, this region. All I have to do is truncate or load my staging table. It looks exactly like the main table I'm going to switch into. Truncate the target table and switch the data in. That truncate, how fast truncate is, practically instantaneous. It just removes the allocation for that data. And then the switch just kind of rewires the storage pointers into the new table without actually touching any of the data rows in the table. So it is also instantaneous practically. I mean sub-second when I say instantaneous. Depends on the table size, but it can really be fast. One gotcha though is anytime you switch into a table, you have to make sure that you update statistics, because when you switch the data into the table, it doesn't also switch the statistics from the source table to the target table. It still has the target table statistics, which might be stale if you just reloaded it with data. And also, if that has an identity column, you need to do a DBCC check ident, to kind of refresh that. So let me show you a couple of scripts here. What I did is I loaded a database. I created several tables in this database, one of which is a 100 million row table, which is kind of a lot for a Surface Pro, but it works pretty well. So what I did is I created a staging table that looks just like the source table. This is just a kind of a dummy demo table, but it has an order create time, customer ID, order ID, and a status description of either shipped or pending, that kind of stuff. And it's a real table. It took me a little while to load it on this thing, but if I just do a select count, from this table here, I'll try to. This is cold cache. I haven't run this query before, so it might take a second. Although it is usually faster than that. Okay, it took a second. Right? Oops. Oh, I had to create my staging table.
as you can see, I have 100 million rows in that, that permanent table that does exist. In the staging table, because I just created it, of course, it's going to be empty here. But what I can do is do a switch, which is a DDL function, you know, a table modification that switches from that source table to, I'm sorry, from the staging table into the source table. So it's going to switch all the data from basically two parallel tables that differ only by name. I should have brought a mouse instead of using this darn keypad. I might need one. If you don't mind. Yes, I can.
I'll take my next week.
Okay, thanks. So in this case here, I switched from the main table into the staging table. So now the main table has 0 rows and the staging table has none. So this is to kind of simulate what I might do if I wanted to do this real fast load I was speaking of. So what my script does is I just truncate the target table, you know, and then I switch the contents of the staging table into the target table. And, you know, I do it transactionally because I want all or none. And let me run just that piece there. Getting that set up, I'll go ahead and just continue to do it with my keypad here. Okay, so that was instantaneous. That was 100 millions of rows of data that I just switched in there. And running the same queries, what I'll find out, of course, is that the staging table now is empty. And the main table will have all 100 million rows. It takes longer to count the rows in the table than it does to move all the data from one table to the other. So that's one use case where you can use the partitioning feature even though your table isn't actually partitioned. Okay, mouse might work a little better here. I haven't used it before, so hopefully I can aim correctly. One of the myths that we have is that large tables are slow. They can be, and I'll be the first to admit it. You know, but usually it's a matter of just having the right indexes on the table. So here I'll just go ahead and, you know, free the procedure cache and drop all the, you know, the clean buffers. So I'm starting fresh here. So let me go ahead and turn on my actual execution plan. And here's a query where this would be a scenario where, let's say at a website where customers log in and they see their orders that they've entered in the last 3 months. So that's what the purpose of that where clause is. So for a specific customer, and in this database, by the way, I have about 100 orders per customer over a period of like 3.5 years. So all told, it has about 100 orders, but within the last 3 months, on average, customers have about 6 orders. Because, you know, it's only the last 90 days. So if I run this query, it'll return the orders for that customer just over the last 90 days. And this first table here is the name implies it's test 1K that has 1,000 rows in it. If I run that guy, you know, it returns real fast. I mean, it's a pretty small table. 1 million rows, you know, for the second table. You know, that one also, if I run, I gotta remember to use my mouse instead of the trackball here. You know, so here's the 1 million row version. It's also pretty darn fast. And mind you, that was on disk. You know, with the SSD is fast enough, so it doesn't really take much time. And of course, 1 million row table nowadays is not big. You know, it used to be like when I started in SQL Server, but nowadays million is like something that you'd run on a PC. Now here's the 100 million row version, and usually that runs a little faster, but I'm not sure exactly why that was that slow. But looking at the, let me run all three of them real quick with the execution plan on, just so it makes it easy to compare the execution plan. Now that it was cached, it was a lot faster too. So if I look at the messages there, I don't know if you can see that very well. I forgot to set my font. But I'll just read it though. We have 2 logical reads on the 1,000 row table, 3 logical reads on the million row table, and 4 logical reads on the 100 million row table. What that means is that it's traversing that B tree that I was showing in that previous slide from top to bottom. So that 1K table only had the root node and the leaf node. That's all I had. It was small enough that it didn't have to have that many intermediate levels. Had one intermediate level for the million row table, so that's why I took 3 level reads and just 4 logical reads for the 100 million row table. So even though it's a relatively large table, it was still very, very fast. You know, because it's able to use that index efficiently. You know, and similarly, like here, I don't even have a where clause on date, so I'm going to return all 100 orders for each of these customers. And again, it's pretty darn fast. And looking at the logical I/O, it's pretty similar. I have 3 logical reads for the first 2, and 4 for the second one. So it really had about the same for the 100 million row table. And looking at the plans, each of these are identical because it's using the same sort. They all have the same index structure, which is a clustered index that has the customer ID as the first position higher key column. So it's able to locate all the rows for only that customer very fast. But if I move on, and then I'll do the go ahead and clear my cache again. And then I'll just skip the other small tables because we know that they're too fast to really be interesting. But if I just do a select count, where I'm just looking at the order status of ship, for over the last 90 days, there's no useful index to satisfy that query. So it actually had to scan the whole table. So if I look at the number of logical IOs here, let's see, what is that? 422,000 plus logical IOs, because I had to read every row in the table. And the execution plan is a lot more complicated here. You see it had to do a full clustered index scan, then the aggregation, but it actually introduced parallelism because it was such an expensive query. So basically, SQL Server through hardware is the problem. So you don't have useful indexes, so I'm going to have to scan the table. I'll throw, I think I have 4 cores on this PC, so that's what it usually has. Degree of parallelism 4 is what it says there. So it was able to do that still relatively fast, but it had to use every processor on the box to process it that quickly. So, the idea is that it scans, at least with the non-partition table, you got to read the whole darn thing from beginning to end. There's no way around it.
The earlier queries that just had 2 and 3 logical reads, so just because of the index.
Yeah, the question is the queries that had just 2 and 3 logical reads. Yeah, it was able to use the same B tree index structure. The only reason it only had 2 versus 3 is just because the more rows you have in the table, the more leaf nodes, the more intermediate levels, because it's building a tree. Once the leaf node gets full, it builds an index level. Once those index levels get filled, it builds another index level, and so forth. Exactly. And the best of my knowledge is really no practical limit to how many index levels you have, but obviously the bigger the table, the bigger your keys, the more levels you're going to have.
You didn't define any partition.
Yeah, I have no partitioning on these tables yet. That's kind of the before picture. The after picture will also be interesting too. Let me go ahead and fire this dude up again. I do Shift F5. So we can do partitioning either using partition views or partition tables. Partition views have been around for a really long time. Before Microsoft actually built native table partitioning into the database engine back, I think in 2000, SQL Server 2000 is when they introduced the partition view, if I remember correctly. The nice thing about partition views, and the reason I mentioned it here, is because that's available in all SQL Server editions. You know, like I mentioned, prior to SQL 2016 Service Pack 1, if you're running standard, your only choice is to use view partitioning. And Azure SQL Database, by the way, has pretty much the same features as the Enterprise Edition does too. So anytime I say Enterprise, I really also mean Azure SQL Database, which is Microsoft, Azure, cloud platform, as a service, or database as a service, sometimes here. So that way you don't have to worry about all the infrastructure and the backups that Microsoft takes all that care for you in the cloud. Microsoft also specifically recommends table partitioning over view partitioning, but I will cover view partitioning really fast here just because it's not all that interesting. But just to let you know what it is, it's really just a union all. You create a query that's a union all views of a bunch of tables with identical schema, and usually you'll have identical indexes too. It's not mandatory that the schema be absolutely identical, but usually people do that in practice. But what actually makes it partitioning is that you put a check constraint on your primary key column, or columns if it's a composite key, that confine the rows for a given table into set mutually exclusive ranges. So for example, I might have a monthly, so I want to have monthly partitions, I would have a check constraint where, where let's say the order date is greater than or equal to the first of the month and less than the first of the next month, and so forth. So every table would have a mutually exclusive, set of rows in it based on the order date. And with that information, SQL Server gets smart enough so that it can eliminate any tables that it doesn't really need from that query when I query that table through a view that's on top of that union all query. And they call that view a partition view because all of its member tables are really essentially different partitions of the same entity. So it's really, it's kind of a neat feature, the way it was built, but there's some downsides as well. Which is why they recommend table partition. It has to be quite apparent. Yeah, there's also the concept of distributed partition views where you can actually just create union all views that are also on top of linked servers. So you can have last year's data on one server and this year's data on another. I mean, frankly, I have not seen that used very widely, but it's possible to do that. But the beauty about partitioning in general is that when a query predicate, meaning something in the where clause or something in the join clause specifies the date, SQL Server can actually eliminate the partitions or tables in the case of a partition view that it doesn't need. And it can do it either compile time or execution time. The downside, though, with one of the downsides with partition views is that you have to to add a partition, you have to basically create a new table, set up the check constraints, and then you have to alter the view to add that new table. And similarly, if you want to get rid of one, you have to, modify the view and drop the table. So just showing what the partition view query plan looks like. In this case here, I just created, let's see, I have to look at my notes here. Yeah, so I have 43 monthly tables. So basically 3.5 years worth of data. And I just use a naming convention where I just use the same table name and just put the year and month at the end of the table name. Here's what the view looks like. It is what it is. And if you think this is bad, I've worked with a company I used to work for. They had partition views with hundreds of tables, and it was based on an identity column, something I would never suggest that one ever do. But you know how it is when you inherit stuff. It's hard to go back and fix legacy applications. but it can get pretty ugly. And just by the way, I was able to at least get those views converted to partition tables, and it greatly helped performance in a lot of use cases. And I'll show you why. Like here, in this case here, this is a partition view on top of those 43 monthly tables. And right now I have a date that's hard coded in the, basically in the where clause. And this is basically the same sort of criteria I had in that other query where I'm just selecting orders for the last 90 days. And in this case here, it had, SQL Server was smart enough not to touch, it only touched 4 of the tables because, you know, one of the partial months here. And it did 2 logical reads on the first table and 3 logical reads on the other 3. So for a total of 11 logical reads. So that was more expensive than actually that single table, as you may remember before, where it only had to do 4 logical reads when it was one big table. So the partitioning did slow things down a little bit, or added some overhead, I should say. But it also provided some benefits in terms of manageability, because now I can just do the index on one of those tables. When I rebuild it, I don't have to do, you know, all 100 million rows. So there is a little bit of a performance cost for this sort of workload, which is more of an OLTP. You know, you have a client that logs onto the website and then they, you know, pull up their recent orders. There might have a slight performance hit on doing so, but again, you have the benefit of the manageability of the underlying table. So it's kind of one of those trade-off things. Yeah, so, and similarly, if I, like this next query doesn't have a hard-coded date, but what it does is it has a, I'm just using the current date, you know, sysdate time to calculate what the 90 days ago is. So instead of hard-coding the date. And in this case here, let's go ahead and, forgot to include the execution plan, but that's okay. This basically has a similar execution plan as the other one. The difference is the execution plan I forgot to include before doesn't reference any of those other tables that we saw that it, you know, hit in the stats. You only saw those 4 tables actually get hit. This execution plan so we have exactly the same number of logical reads. It looks very similar, but this execution plan actually has to consider every single one of those, you know, 43 tables. So, I mean, this is a big execution plan. And as you might think, it takes a little bit longer to compile a query when you have a big, you know, query like that. So if you have a bunch of, you know, clients all hitting the same table and, you know, and they have to compile their queries, that can take a little while. You know, cumulatively in terms of CPU time and stuff. But what you see here is that after each one of those index, or before I should say, each one of those index seeks, there's a filter. And SQL Server, you know, when you use partition views, it puts what they call a startup expression in front of that table seek. So therefore, if that startup expression is false, it doesn't even touch the table at all. So it actually put in a query plan, essentially like a mini where clause that said, hey, when this query starts up, don't bother to touch this table if the date range, you know, won't, if it doesn't need to touch that table because of the date range that you're using. So that's a kind of a pretty cool feature. Although, like I said, the query plan is fairly complex here. Now, if I just use the that same query where I did that count, you know, earlier, where I don't have a customer ID, I basically have to do a full table scan. But still, I'm kind of confining it to 90 days. Yeah, the execution plan is a little bit nastier. It still has the same sort of structure in terms of the filter in front of the clustered index scan, but it has to concatenate the, you know, the results from each one of those tables that it had to hit and had to throw parallelism again at it again and all that. And again, even though it has 0 for all the other tables in terms of its logical read, the tables that it did have to touch in this particular plan, you see pretty high counts here in terms of the number of logical reads. So, it's better in some cases, but it's not, 100% the best thing in the world, and that's why we have table partitioning. Does anybody have any questions? I meant to stop earlier.
There's maintenance for statistics IO and checkpoints stuff there. If you do that drop clean buffers and free proc cache, that's something that's only safe to do like on a local machine. Like you would want to do that on a production server.
Yeah, that's a good question. Which is the DBCC drop clean buffers, free proc cache and all that. Yeah, typically you would only do that on a test box, not in production, unless you are specifically trying to test performance on your production box outside of production hours. Because the reason is the drop clean buffers will really just unnecessarily evict all the data buffers from cache, so everything has to get read from disk next time the data is used. The free proc cache clears all the procedure cache, all the execution plans out of cache. And generally you want to keep them in cache unless they're a bad plan or something. And that's another side discussion there. But generally, yeah, you don't want to free all of your procedure cache at once on a production server. It's just like restarting the box cold, Brad.
So I just wanted to make sure that it seemed like a dangerous thing to do in production.
Yeah, to get good logical or to avoid any caching of prior queries for this demo and stuff, I put all that stuff in there. So this is a quick compare and contrast of table and view partitioning. With table partitioning, you can't have any, or you don't have any gaps. You have a partition for every possible value in your table or in your entity, as the case may be. With a view, you can have gaps. So you can forget to, for example, have a table for a given month, or you could have check constraints that won't fit your data. So if you try to insert into the partition view, and there's no table that will allow your insert will fail. Having seen that happen, because if usually when you have partitions like that, you'll also have some sort of automatic job to add these partitions, over time, especially if it's by date. And if that job doesn't run for some reason, or somebody forgets to run it, then lo and behold, it fails later. With table partition, you have a single schema because you only have one table, but you could theoretically have different column name schema and even indexes on a partition view. I have seen that happen accidentally, where they create an index on one table and not the other table, and it really makes the query plans ugly. They're not even symmetrical. The SQL is going to evaluate each table independently, and it gets really nasty. You may or may not know this, but if you ever do a bulk load into a table without that check constraints option, in order to do it fast, that will actually cause your constraints to become non-trusted, specifically your check constraints and your foreign key constraints. So what that means is that if I do a bulk copy into a partition view member table, because I can't do it directly into the view itself, what I'll have to do is what that'll do if I have don't have that check constraints option, it will cause the constraint to be not trusted. Then the optimizer can't eliminate the table because it's not 100% sure that it doesn't have bad data or you get wrong query results. So that's another reason that table partitioning is generally a better option. And the query plans are typically much simpler with table partitioning, as you'll see in a second. And I mentioned about the bulk insert. Yeah, you can't bulk insert into a view. So a partition table looks a heck of a lot like a regular table, except you have multiple partitions essentially. The key point, though, with a partition table is that you also have a boundary between your partitions. Whereas
still have the regular deep tree index structures for your clustered and non-clustered indexes. But in each of those partitions are at a storage level are independent of the other. They're just kind of wired together as part of the same table. But we can operate on individual partitions on that table when like doing that switch operation like we did before. Or for other purposes such as rebuilding indexes and stuff. For example, if this is a 100 million row table and each one of these partitions only has a couple 100,000 records in it, I can do an index rebuild on just one of the partitions and one of the indexes instead of doing it on the entire table. So it provides a lot more granularity in terms of maintenance. And that helps shorten the windows for maintenance. Now there's let's see.
Discussing that in a second. So I want to jump ahead of myself.
But essentially, oh yeah, I forgot to throw it out there. When I say align, that means that all of the indexes and table and the table itself, the clustered index, are all partitioned using the same, basically the same partition function is what I'm getting at. So that way they're all partitioned similarly. You can partition a table of indexes independently of one another, or you can even have a non-partitioned index on the partition table. All sorts of different combinations thereof. But usually that's not commonly done. Usually it's most common to have everything aligned, meaning they have the same partition function. You have everything on the same file aligned so that you can use switch to move data in and out of two similar tables. That's one of the big benefits of partition in general is the ability to operate on subsets as part of the ETL process using switch. Not to say there aren't other use cases, but that's definitely one of the most common ones. Just like with the view partitioning we saw, SQL Server can eliminate unneeded partitions during query execution with seek predicates. But what makes it a little bit different is that with table partitioning, it doesn't have to insert that filter directly into the query plan like we saw. Instead, it actually uses it does the partition elimination with a seek predicate, just like it's an index on the underlying partitioning column. You'll see that in the query plans in a minute here. And just as an aside, the more complex your executions plans get, the more likely SQL Server is to make the wrong choice in terms of what indexes it uses, or you have a query that takes forever because it went south. It's not, just not using the right index. SQL does get dumb, if you throw too much at it. Just like it gets overworked if there's too much going on inside of a query, especially when you have a lot of joins and those kind of things. With table partitioning, because it does simplify the queries quite a bit, chances are it's going to result in less complex queries to the point where things, go south on it. So that's one of the benefits of table partition. Natively, it's a range of values that you specify. The first, really what a boundary is, or partition boundary, I should say, is or each partition has a boundary between it. There's always a boundary between partitions, and ultimately that's going to boil down to a range of values that are allowed within each partition. I'll show that in here. The first partition in the table, though, has no lower boundary, and the last partition has no upper boundary. So you might even think about that almost like it's a non-partition table, because technically you can have a partition table without any partition. Looks exactly like a non-partition table where you only have a single partition, but you haven't defined any boundaries. So that one partition is the one and only place for all data in the table. You can also have, instead of range partition, you can functionally get a list partition, like I was mentioned earlier about a scenario where you might have different sales regions, east, west, north, south, whatever. You could put a check constraint to allow only those regions on a partition table, but the actual boundaries would be the names of the regions themselves.
And I don't even want to discuss hash partition. That's kind of like sharding. Sharding is just like fingernails on a chalkboard to me. In most situations, sharding is the way you would, it has use cases, but that's mostly for distributing workload across multiple servers, not to split, data within a single database. So the key elements of table partitioning are a partition function and a partition scheme, which are database scoped objects. So, tables, you have a schema, DBO dot table name or site host dot table name or whatever. Partitioning schemes and functions are not database scoped. They're, are database scoped. They're not schema scoped. And the partition function just defines the boundaries that are used in the partition scheme that's associated with the partition function. Just list the file groups that the objects that you create partitions on, what file groups they get, put on. That'll become a little bit clearer when I show you the actual diagram, this DDL. The partition function specifies your partition column data type, as well as a range specification, left or right, which I'll do, and list the boundaries of partitions. So I like to think about it like it's just a list of the boundaries between partitions, mostly the data type, and like I said, the left or right range specification. The way you use the partition function scheme after you define them is that, they just stand alone. They don't allocate any storage until you actually partition an index or table using the partition scheme. So you never reference the partition function directly when you partition a table. You reference the partition scheme because it's just like an on clause. You say on file group, you say on partition scheme, which is a list of file groups, and then based on the partitioning column value, it'll determine which of the file groups that a given partition is put on. You can pretty much partition on any data type except for the big ones, XML, text, and text image, any of the max types, watercolor, max, CLR types, time span, rated. You can have up to 15,000 partitions on the table, and that's quite a lot. I haven't come anywhere or seen anything near that myself, but that is in modern procedural versions. I think before it was increased in one of the 2008 service packs, it used to be like 1,000 partitions in 2005. You can also invoke the partition function as a scalar function to return the actual partition number for a given value, which is really handy with maintenance scripts. One of the most confusing aspects about a partition function is that range specification, where you say left or right, and I've seen that trip up a lot of DBAs, and that's why I like to very much call that out here. What it does is it determines which of the two partitions that are adjacent to the boundary actually contain that boundary value. It will also determine what partition gets created when you split a partition function, which partition gets removed when you merge it. Those are split. I'll talk a little bit about split and merge, but split means I want to create a new partition. I'm adding a new boundary. Merge means I'm getting rid of a boundary, so I'm going to remove a partition. And it also determines a permanent partition file group that you can never get out of the partition. It's a little bit of a gotcha, which I'll speak to in a minute here. You can have multiple partition schemes that use the same function, and that's fairly common especially when you have a table and an index, and you want to partition both the table and the index. Yet you may want to, rather than using the same partition scheme, you might put the index on a different set of file groups or something. So you might have a partition scheme for your indexes, partition scheme for your data, but you would still have both those partition schemes that use the same partition function. They both have the same boundaries because you want to get these things aligned. thing to remember though is that you can, there's nothing that would stop you from having one partition scheme and one partition table and having, and having many partition tables that are partitioned using the same objects. The gotcha though is that whenever you add a boundary, any tables that are using the partitions, the function schemes that are, that touch those, they're all going to get affected. So if I, for example, want to add a new month to a partition function, and I do that, and I have 1,000 tables that are all using that, partition scheme, they're all going to get split at the same exact time. And that may be not what you want. You may want to have, for example, you may want to have all of your sales data partitioned based on, your sales month, if you will. And maybe have some invoice data that's a separate structure is maintained as part of a different process. You may want to do that based on your invoice data. Well, you probably want to have different partition functions and schemes for that. You don't want to necessarily try to reduce the number of partitions, functions, and schemes. And I would actually make the argument if you're going to err on the side of having one per table, kind of, or one per, index, if you will. It's better to have too many than not enough. Okay, finally getting back to some SQL. This is my role. I like the SQL stuff. I hate PowerPoint bullets. So this is the DDL that you can use to create a partition function. In this case here, it's a range right function or a date time to column. I like to use date time to instead of date time because it's more precise, use less storage, there's no downside basically. I'd only use the date. If I need both date and time in the same data type, I would avoid date time unless I have legacy data that I have to join with. They don't live very nicely together when you convert it from one to the other. But date time too is definitely the way to go. That's my soapbox. But in this case here, the partition function, you can see we have two boundaries for the first of the year for both 2017 and 2018. That's because I'm partitioning based on the calendar year. The partition function, I list 3 file groups. And that's because when I create a partition function, I'm defining boundaries between file groups, between partitions. And there's always going to be one more partition than I have partition boundary. So the end result of that partition function, because it's a range right function, is that the first boundary that I created was 2017, and that got put on the 2017 file group because that one is to the right of this boundary. And same thing with 2018. And I think this probably illustrates a little bit better in terms of graphically. So, it's the same exact partition function scheme. You can't see the smaller print here. But when I create this boundary or specify this boundary, it's the partition on the right, which is the second partition table that boundary defines. And because there always has to be a place for all data in the table, anything less than this goes to the left of it. And similarly with the second boundary, the partition on the right, which is partition 3 here, it actually includes that boundary. So partition 2 in the middle functionally is just like saying greater than or equal to this boundary and less than the following boundary. And personally, I always recommend using a range right function unless you have a specific reason to do otherwise, which I have yet to run into. Yes, sir.
So that, can you go back?
Yeah.
So that partition 2, I got you. Let's just try and, I got it. Never mind.
Okay. Sure.
Yep, I'm positive.
Okay. Yeah, I mean, if you have any questions, feel free to speak up or that we can talk afterwards. I'm going to be running a little behind here, so I'm going to go relatively fast. But similarly with range left, it's the partition on the left that includes the boundary. And it's really kind of, in my opinion, kind of unnatural to specify, use range left with any temporal types, like anything that has a time, because now to get the behavior I want, which is say every possible row in the same partition for that year, I have to go to the highest possible value for that date. Like in this case here, it's a date time 2. So I have to say, you know, and with no precision, so I don't have any fractional seconds here. So the highest possible value for a given year would be 50, or, you know, basically 1 second before midnight. You know, and it just feels wrong. You know, it's even worse though when you have a date time type, because you know date time is only accurate to 1/300th of a second, so the values always end in either 0, 3, or 7. It's really ugly, because then I would have to say, you know, 59.997, and if I accidentally said like 999, which would think, hey, nothing's gonna be that, it would have rounded that up to the next year, and then I would end up with dates that are always that fall right on the year in the wrong partition. So it's a kind of a gotcha there. So just use range right and stick to exact year boundaries or month boundaries or day or whatever you're using. Don't try to do this, because I've seen some of the some blogs where they do this, and it's just kind of, like I said, it's kind of natural. So similarly, so here's what the range left function, you know, look like. Well, I didn't do that already. Ignore that slide.
Left, and then just make it available.
Yeah. That's a good question. I have yet to really run into one. I think Microsoft erred on that one. They should have made right. Matter of fact, I shouldn't be configurable in my opinion. There may be a reason, but I just don't know what it is, why one would even have a range left, frankly. At least with any sort of incremental boundary, which is the most common use case. Now, if you're doing like list partitioning, then it probably doesn't make a whole lot of difference. And you can even make the argument, maybe it's more natural the way you think about it. So essentially, this is the similar, you know, thing with the range left. Yeah. So how much time do I have, Julie? Okay. I should have planned a little ahead. I wasn't sure how long some of these things going to take here, but I think I'm doing all right. I should be able to cover most of the salient points. So that's the main thing I'm trying to do here. Yeah. Okay. All right. So here's the same sort of structure. I mean, in terms, same exact data, same exact table schema. What I did here is I created a partition function with, as the note says, I have 44 monthly I have 43 boundaries, which creates 44 partitions from 2014 all the way up to the first of this month. So I did that in a script because I didn't want to sit down and type every date for, you know, every month and date for 44 years. But this is a common sort of script you might see in partition maintenance to, you know, create them ahead of time, you know, just in a little loop. So what this does is I create the partition function, and then I just do a little while loop that first thing I do is set the partition scheme next used, which tells it what file group to create the new partition on. And on my servers here, I don't have a whole lot of disk drives. I have like one. They won't even let you add anymore, you know. So everything's on my primary file group on my C drive. And then I alter the partition function to split the range at that date. So I basically started the first of the month 2014, and the 1st of January. Then I go to the 1st of February and so forth. It just keeps splitting until I create them all. And then at the very end, I go ahead and just create my, I forgot the, yeah, I created that ahead of time, I'm sorry. So anyway, I created the partition scheme first, and then I moved around these comments, my bad. But anyway, the last thing I did is I created the partition table, and this is just like the other one. The difference is though, I said on and then I gave it the partition scheme name and the name of the partition column in parentheses. So that tells it, hey, use this partition scheme, which is the file groups to create it on, and partition on this column. And I have roughly about, like I said, about 2 orders per month per customer or something like that. But all told, it's the same 100 million row table that I had before. So here's what the query plan. I got to make sure I include that. Okay, so you saw how fast that just came back, and that, mind you, that was against a cold cache. I think. Yeah. So I have 4 logical reads, which is identical to, I'm sorry, I said that wrong. I have 11 logical reads, which is identical to the same thing we saw with the partition view. I see 4 scans, which is basically one seek per partition. But let's look at the execution plan here. The bottom one is just for the VNV. This is the execution plan. It's nothing more than a clustered index seek. So instead of having that nasty plan where it hit 144 different tables, all we see is that clustered index seek. And like I said, that's a lot simpler. Furthermore, if I pull up the properties for that, I don't know if you can see this very well, but at the very bottom here, it says optimization level trivial. I forgot to call that out on the partition view query, but SQL Server considered this to be a trivial query. In other words, it's a no-brainer. It knows how it's going to run the query, and it compiles very fast. And furthermore, it can even parameterize the query automatically. Even though I have a date literal on here, SQL Server chose to auto-parameterize this query, as I can tell when I selected the query, the query text from the cache, query stats. This is basically represents the partitioning column value as well as the customer ID. So even if I run the same query again with a different date, it could, theoretically just reuse that same execution plan. So that's another benefit of the simpler query. And even without the hard-coded date, if I run this thing, it's pretty much it's going to get the exact same, execution plan. It's just all we see is a cluster index seek every time. It's much cleaner. Now, if I guess I should look at the query plan here. So I don't know how well you can see that at the bottom where it says seek predicate. But really what it's doing is it's evaluating the partition function. So it kind of like incorporates the partition function in the seek predicate to figure out which partitions to hit. And then it runs the value that I had specified in my where clause to figure out, what the partition number is to actually collect from. But the storage engine does that all, at the low level. It's not higher level in the execution plan, like it is with the partition view. And if I don't show the, if I don't have the partitioning column, in the where clause, so it's going to have to read. I'm basically asking for all rows for all times with the customer ID. This returns about 100 rows here. I see 44 scans, which is exactly the number of partitions, and I have 128 logical reads, which isn't all that great compared to the non-partition table, which I don't know if you remember, but with the non-partition table, this same query was I think it was 4 logical reads because there was only one partition. It didn't have to do that each read seek into every single partition that it hit. So this is essentially 3 or 4 logical reads per partition. So it's more expensive for this particular query when it becomes partition. So the moral of the story, and the reason I bring this up, is that be careful if you have queries that do not specify the partitioning column and it's an OLTP workload where you're only trying to grab a few rows. It's going to cost you. So this is one of the biggest gotchas that people think, oh, I got a 100 million row table. I got to partition this thing. And you do, but then, you know, your users start complaining because things slow down. So, you know, just be careful. Do your due diligence. You know, I like to, and frankly, partitioning is an advanced topic. It's nothing that's, you know, 101 DBA event. Some people say, I mean, I think it's kind of intermediate to advanced. Some people say it's an expert topic. I wouldn't go that far. I think if you just play with it, you know, you really become more familiar with it and comfortable with the future. It's pretty cool, actually. Okay, so here's that aggregate query that I had earlier against the partition table. I mean, similarly, this one isn't going to perform all that thoroughly. I mean, again, it's got to scan everything. It's doing a clustered index scan as you would expect. It's very similar to the non-partition table. You know, lots of logical reads. But the reason I mentioned that one is let's fast forward a little bit to another partition use case. And this is why I was asking about Columnstore before, especially on the for a decision support type workload where you do analytics. So in this case here, same exact partition function, same exact partition scheme. The only difference is instead of just a regular traditional clustered B-tree index, I created a table that has a clustered Columnstore index on it. And that has a number of benefits that, you know, this isn't a Columnstore presentation, so I'm not going to dive deep into that. But I do want to illustrate some of the benefits when it comes to partitioning on Columnstore. Because Columnstores are kind of funny in that they're optimized for scans. They're meant to be scanned from beginning to end, you know, large data sets, etc. They have a high level of compression, and kind of sort of like partitioning, SQL Server breaks that Columnstore index into multiple million row, what they call segments, or, you know, row groups. And anyway, since I don't have a B-tree index by default, not optimized for scans, typically it's going to be, you know, without the regular Columnstore, like here's that, you know, select all data query, you know, select count. You know, this is against the cold cache. And this one, you know, the IO stats are a lot different because of different structures of Columnstore. I had to do a lot of logical reads, but it is much faster typically than a traditional query when it comes to scanning a lot of data. So it's doing a Columnstore index scanning. But the reason I want to point that out is you can put partitioning on top of a Columnstore as well. Like here right now, I'm doing about 200,000 logical reads to scan the entire Columnstore organized table. So this is a identical copy except it's partitioned. When I run this one, you may have noticed it did come back a little bit faster. And again, that was with the cold cache. The execution plan, it didn't even use a parallel query because it was below the default, you know, cost threshold for parallelism. In other words, people said, why bother? I'm going to run this real fast. And it did. And then if I look at the number of logical reads here, it's only like 14,000 logical reads compared to the 200,000 when it was not partitioned. And the reason is SQL Server, even though this says scan, you can still see that it has a seek predicate. So it's kind of like a partition table or even a partition Columnstore is almost like adding an index that has that partition column as a high order key column. SQL Server can use that to touch only those you know, partitions that it needs. So it runs much faster. But because nobody's really used Columnstore before, I think that's some good homework. If you have the ability to do so, and you have a workload where it's appropriate, do a little homework and play with it. It's really a cool feature. I personally hadn't had to use it until relatively recently. I was building basically a data mart for some performance data, you know, where we collect a bunch of P-mod stats and all. And I was really amazed how much compression I got. I mean, I got like 90% compression of the data compared to just a regular row store table. And I was able to like do historical capacity planning analysis like in the drop of a hat. mean, it was really, I was very impressed by it all. Running late? Yeah, the question about Columnstore, Columnstore is memory hungry. Now, that being said, I just did a Columnstore index rebuild, build, I should say, on my Surface with 8 gig of memory, 100 million row table. You know, this is, you know, in the whole thing, well, to load all these tables on my Surface, it takes about an hour, you know. Mind you, that's because I'm generating all this data and I didn't optimize my queries as well as I should. The most expensive part of that, by the way, was inserting into that partition view directly, because I didn't go into the individual member tables. But generally speaking, it's better to have as much memory as you can on a database server anyway. But Columnstore is kind of funky the way it works. And like Julie said, this isn't a Columnstore presentation, and I'm pretty new to it myself. But I have learned that what it tries to do basically is grab about 1 million rows at a time and create what they call a row group out of it. So it gets a chunk of 1 million rows from your table when it's building the Columnstore for the first time. It compresses it, you know, as well as it can using like a dictionary type compression. And, you know, if it has enough memory, it'll do 1 million of those rows per segment. Now, if you don't have enough memory, it'll make it much smaller. It'll only do like 100,000, which is the minimum size of rows per segment. So what we end up with is a lot more segments with a fewer amount of rows. And the more segments, the less optimal it is to scan. And then you end up paying for it later when you try to query the table. It has to kind of do that segment elimination. So it has to pull that data in memory, the metadata in memory. And I've seen questions in the forums where people run into problems with that. I mean, this guy, this one guy, I think he had 60 billion rows in there. He's running with like I think it was 100 and, oh God, I forgot the exact amount of memory. Shoot. Anyways, many terabytes of data. And he only had like 128 megabytes total on his, 60 billion rows. And these are wide key. I'm not talking about these little things that I'm talking about. He had a lot of wide strings in his, and he was running performance problems because of the Columnstore metadata. But yeah, it very definitely, memory is a consideration with Columnstore, as it is with, because Columnstore technically is a memory optimized technology. It's optimizing it for scans. But thanks for bringing that up, Julie. I should have mentioned that. Let's see. I already mentioned some of that.
One question I've got, Dan, is like, how far out a feature do you go? Like if you're doing partitions by, like say by year and months, do you go out like 20 years into the feature so you don't have to touch any of this stuff for a long time? Or I've heard people running into issues at work about having to remember to add the next year's partition on before you get to the end of the year and things like that.
Okay, so the question is, when you're planning your partitioning strategy, especially when you're talking about incremental date like we've been kind of showing here, how far in the future do you create those partitions? 1 month, 2 months, 20 years, you know, whatever. The answer is it kind of depends. One of the mistakes that I've seen and that you kind of alluded to is that for some reason people like to create one file group per year or per month or whatever that thing is. My question is why you're doing it. If you don't need to do it, don't. Just put everything on the same file group. But if you have other RPO requirements or something like that, it might make sense to do it. Or RTO, I should say, so you can do that, you know, piecemeal restore. But the gotcha with file groups is you have to create those manually, because usually you also attach new storage to your, you know, from your SAN or whatever, and you create the file groups, and it's kind of a more of a manual type process. Usually what I see is DBAs, you know, do like an annual run book kind of thing where they'll say, well, here's my tables that I need to create. I need to get the storage guys to give me more storage, and then I'll create my file groups for the next year. I'll create those file groups in advance. But the actual partition maintenance job, they can either create those all in advance manually, or you can have a like if it's a sliding window where, you know, you're rolling off, you know, like a certain number. You can fully automate that, because typically with that kind of a scenario, you don't have your separate file groups, or at least file groups that are, you know, structured that same way, like for by year and stuff like that. So it kind of depends on the scenario, but generally I'd recommend that if you're doing like monthly partition, I would create an extra month in the future. That's why I kind of recommend that you create, I think I do have that sliding window. I'll wrap it up in a minute here. To kind of show you what my recommendations are on that specific subject. So, but again, it's not a one size fits all thing. It's going to depend on your specific environment. Okay, so if I create a partition function with no boundaries, I'm going to have a single partition, you know, nothing in it, just like a non-partition table. But I want to create a new partition, so I do an alter partition split to create that new boundary. I just want to show you really what happens and try to underscore one theme before we finish for today. It creates the new boundary, and because this is a range right, the key is that boundary gets created to the right of that boundary. And if there's data in that partition, it's going to have to move the data, you know, from the original partition into the new partition. Like in this case here, anything that's less than the first of the year, it's going to have to move into that new partition. And it's best to avoid splitting non-empty partitions. So try to avoid do it, because, and you know, I was sure the range left is essentially the opposite. You know, it just moves everything from the right to the left and creates the new partition on the left. The reason is when you split a boundary or split a partition function that has data, there's about, I'll just speak to it. There's about 4 times the logging that would happen compared to just a regular like delete statement or something. And a lot of times it's a double whammy, because, okay, I partitioned the table because it's humongous. I got this humongous partition, I need to create a new boundary. And then I split the boundary that already has data in it. And now it's going to do 4 times the logging than it normally would. Guess what happened? The thing runs for hours and hours and hours. And guess what? The transaction log fills up. It goes in the rollback. It's faster to restore the freaking database than it is, you know, I've seen that happen quite a bit. So really be careful when you do partition maintenance, so that you split and merge only partitions that don't require any data movement, which typically just means, the short answer is just dumb it down, keep them empty. And that means, to your point about, you know, planning in advance, how many partitions should I create in the future? Create enough in the future so you don't have to, you want to split before you start loading data into that month, not afterward. And if you have to create file groups and this manual type stuff to do that, set up a reminder job, an alert or something, so that, you know, as that date approaches, don't wait until you get data in there before you start, you know, scrambling to, you know, add storage and stuff. You know, and similarly with merge, which is the opposite, it's the least partition function. I'm sorry, partition boundaries. You know, it has to move data into the retained partition. And again, that causes a lot of data movement too if you haven't planned ahead. So the key point being, hey, you know, don't split empty partitions. So anyway, I'm running over, so I'm going to have to cut it short here. Show you a little bit of sliding window DDL and stuff. But anyway, that's pretty much most of the points I wanted to make. My apologies. This is a big topic, and I redid the presentation to try to cover some. Like I didn't have any of the Columnstore in it before, and I think that's an important thing to cover. here, especially for the DI. So, I didn't have a chance to really work through all the time and everything. Plus, I didn't know Julie was going to take up the whole first 15 minutes.
You can have 15 minutes.
Nah, just kidding, of course. Yeah, but we will put the slides, all the scripts, so things that I didn't have to get a chance to cover at the end, they will be available for your review, by download and all that kind of stuff. I definitely appreciate your time. And again, please do fill out the feedback and provide, constructive feedback to make this thing better next time. Thank you.